this section, we're going to take a look at the algebra of functions, composite functions. So this is the composition of functions. The big focus here is really notation, is quite honestly the biggest trouble, trouble spot that I see with students is the notation of what we're looking at. So just some notation that we're going to be upfront with is the sum of two functions is f plus g of x, or f of x plus g of x. So if you have f plus g of x, that's taking f of x plus g of x. The difference of functions, f minus g of x, equals the f of x minus g of x. So you're subtracting the two functions. The product, f times g of x, is f of x times g of x. And then the quotient, f divided by g of x, is equal to f of x divided by g of x, where g of x cannot equal 0. So in the letter A, f plus g of x, we are taking this as f of x, this is g of x. So that means we're taking x plus 3 plus 3x minus 1. We're taking f of x plus g of x. We're adding the two functions together. So when we do that, though, we have to combine like terms. So x plus 3x is 4x. 3 minus 1 is 2. So we get 4x plus 2 for that one. Subtracting the functions, f minus g of x, that is going to be f of x minus g of x. Be careful how you write this. So f of x is x plus 3 minus 3x minus 1. So x plus 3 minus 3x plus 1. X minus 3x, so 1 minus 3 is negative 2x. 3 plus 1 is 4, so negative 2x plus 4. Letter C, f times g of x, meaning we're doing f of x times g of x. So f of x is x plus 3 times g of x is 3x minus 1. So we have to multiply it all out. So binomial times a binomial, x times 3x, x times negative 1. 3 times 3x, 3 times negative 1. X times 3x is 3x squared. X times negative 1 is negative x. 3 times 3x is 9x. And 3 times negative 1 is negative 3. So we have like terms in the middle. 3x squared, negative 1 plus 9 is 8. So 8x minus 3. So 3x squared plus 8x minus 3. Done. And last one, f over g of x, meaning f of x divided by g of x. So f of x is x plus 3. G of x is 3x minus 1. There's nothing that we could really do other than establish what x cannot equal. X cannot equal 1/3 because 3x minus 1 equal to 0. Take the denominator, set it equal to 0. Solve, so I get 3x equals 0 plus 1 is 1. Divide by 3. X equals 1/3, so that means x cannot equal 1/3, because if x is equal to 1/3, then we get 0 in our denominator. So that's the only restriction there. So x cannot equal 1/3, because we cannot have 0 in our denominator. So those are just function operations. These are skills that should have been addressed previous, but I just wanted to introduce this as notation to understand what is the difference between addition, subtraction, multiplication, division, because now we're going to look at the composition of functions, and the notation may look somewhat similar to this. So the composition of functions notation is f of g of x. Notice how I'm saying it, f of g of x. This symbol here, that is not a multiplication symbol. That symbol is used for composition of functions. It's not a multiplication. Multiplication is this. Just a single dot is multiplication. It's not the same as composition of functions. So don't mix up these two symbols. That is not multiplication. And I'll show you multiplication right here. That is multiplication. Not multiplication. So composition of functions means that you are taking a function and you are plugging it into another function. So just like if I asked you what is f of 2 and I gave you this function of x plus 2, you would say, well, 2 is my x value. I'm going to plug in 2, so I'd have 2 plus 2. This is doing the same thing, but with a function. So if I'm taking f of g of x, and there's another way to write the notation, these are the same things. I'm taking g of x and plugging it into f. The easiest way that I can just help you remember this is like, how do you know if you're plugging f into g or g into f? Whatever's coming second. So if it's f, the composition of f and g like that, so f of g, that means you're taking g, plugging into f. If it was this, g composition of f, then you're taking the f function and plugging it into g. So whatever comes second, that's how I was just, okay, so f came second, so it's going back into g. And then I even rewrote it here. So if it was g, composition of g and f like that, that would be g of f of x. That's taking the f of x function and plugging it into the g of x function. Let's look at some examples. So number 2, if f of x equals x squared and g of x equals 2x plus 1, letter A is asking us find the composition of f of g of 3. That means we want to get the composition of the g of x function into f and then evaluate 3 into that function. So we're going to do the composition of g into f, because this is technically f of g of x. But then when I get that answer, I'm going to take 3, I'm going to plug in 3 for x. So let's just do one step at a time. We have f of x equals x squared, g of x equals 2x plus 1. So that means I'm taking g of x and plugging it into f, because it's f of g. If it was g of f, we take f into g. I'm taking g into f. F is x squared, so I'm replacing x with 2x plus 1. That's what I'm doing. I'm replacing x with 2x plus 1, because just same thing. I'm going to do this again. If I gave you just side example, if I gave you the function like x squared plus 3x plus 5, and I said evaluate f of 3, what would you do? You would take 3 and replace any x value with 3. You'd say 3 squared plus 3 times 3 plus 5. Right? You take every x out and replace it with 3. This is the same thing. If f of x is equal to x squared, wherever I see an x, I'm replacing it with 2x plus 1. Let me just make one more note here. Let's pretend, I'm going to erase this. Let's pretend f of x was x squared plus 2x plus 1. Or, no, bad, because that's the same thing there. 4x minus 5. Let's just say that. And I asked you to do the composition of f of g. You would take g, which is 2x plus 1, and replace every x value with 2x plus 1. So this would translate to 2x plus 1 squared plus 4 times 2x plus 1 minus 5. See that? So I left f of x, and I'm doing the composition of f of g. So g is going into f, so everywhere I see an x is being replaced by g. I like going to that like more extreme type of example to help you understand the simpler examples, because I think that helps it illustrate a little bit better of like, oh, I'm just replacing every single x with an entire function. So here, my f of x function is x squared, replacing with 2x plus 1. So this is going to be 2x plus 1 squared. Because f of x was x squared, x is now 2x plus 1. So it's 2x plus 1 all squared. Two options here. You can go through and multiply all this out, but since they're asking us to evaluate 3, like they're saying like get f of g of x and then evaluate 3, just go straight to the plug-in of 3. So this is 2 times 3 plus 1 squared. You don't need to go through the whole process of actually expanding out 2x plus 1 squared. This is going to be 2 times 3 is 6 plus 1 squared. 6 plus 1 is 7. 7 squared is 49. Next, letter B, g of f of 3. So now we're going the other direction. We are taking f of x and plugging into g of x, because this is g of f of x. And then we're going to evaluate 3 into that answer. So taking f of x and plugging in for g. So wherever I see an x in g, I'm replacing it with x squared, because that's what f of x is equal to. Just like how I replaced every x in f of x with 2x plus 1, because that's what g of x is equal to. So I'm doing now the other direction. So put in x squared into g. So it's going to be 2 times x squared plus 1, just like that. And then now we have x squared. So I'm going to take x And we can multiply all this out. It's just going to be 2x squared plus 1. There's really nothing else that we can do. But now I got to evaluate 3. So I'm going to plug in 3. So 2 times 3 squared plus 1. 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. Okay. In letter C, they just want f of g of x. So that's just saying find f of g of x, meaning take g of x and plug it into f. We already did that over here on letter A. The only difference was this one actually wanted us to evaluate a number. But we're going to go back to here, his 2x plus 1 squared. Since they want us to actually get the function, we do have to now expand this out. So we have to fully multiply this out. So this is going to be 2x plus 1. This is going to be 2x plus 1 times 2x plus 1. So 2x times 2x, 2x times 1, 1 times 2x, 1 times 1. 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is 1. Getting a little close to my camera there. I'll move this over. So this is 4x squared. 2x plus 2x is 4x plus 1. So you do actually have to expand that one out. So composition of functions, it's really a notation thing. I have one more example here that we'll do. If f of x equals the square root of x and g of x equals x plus 1, find f of g of x and find g of f of x. So this is f of g of x, and this is g of f of x. So the notation here, whatever's coming second is going into the first. So g of x is going into f of x is going into g for letter B. So f of g of x, taking g of x, wherever I see an x in f, I'm replacing it with x plus 1. So this is going to become the square root of x plus 1. See that? Because f of x is the square root of x. I'm replacing x with x plus 1. So it now becomes square root of x plus 1. I have nothing else that I could even do there. Let me make sure this is my last problem. Yeah. And then g of f of x, I'm taking f of x, plugging into g. Wherever I see an x in g, I'm replacing it with the square root of x. So now square root of x is going to go here. So that's going to be the square root of x plus 1. Nothing else to do there. Composition of functions. There it is. It could get pretty crazy at times, but these were a little bit more manageable situations, but it can get pretty complicated when you're really getting into some crazy f of x and g of x functions.